Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is surface chemistry, adsorption and catalysis. Surface chemistry plays a crucial role in various chemical and industrial processes, particularly in adsorption and catalysis. It focuses on the interactions occurring at the interface between different phases, such as solid-liquid or solid-gas interfaces. These surface interactions influence the behavior of materials and are widely applied in industries, medicine, and environmental science. Adsorption is the process where molecules from a gas or liquid accumulate on the surface of a solid or liquid. Unlike absorption, where molecules penetrate into the bulk of the material, adsorption is confined to the surface. This phenomenon occurs due to unbalanced attractive forces at the surface of a material, which pull in molecules from the surrounding medium. Depending on the type of interaction, adsorption can be classified into physical adsorption and chemical adsorption. Physical adsorption involves weak van der Waals forces, allowing molecules to be loosely held on the surface. It is reversible and influenced by factors like temperature and pressure. Chemical adsorption, on the other hand, involves the formation of strong chemical bonds between the adsorbate and the surface. This type of adsorption is usually irreversible and plays a crucial role in various industrial processes. Adsorption has numerous applications, such as in gas masks, water purification, and chromatography. In gas masks, activated charcoal adsorbs toxic gases, preventing them from entering the respiratory system. In water purification, harmful impurities are removed by adsorption on porous materials. In chromatography, separation of components in a mixture is achieved by their differential adsorption on a stationary phase. Another important concept in surface chemistry is catalysis. A catalyst is a substance that alters the rate of a chemical reaction without undergoing any permanent change itself. Catalysts function by providing an alternative reaction pathway with a lower activation energy, making the reaction proceed more efficiently. Catalysis is broadly classified into homogeneous and heterogeneous catalysis. Homogeneous catalysis occurs when the catalyst and reactants are in the same phase, often in solution. In contrast, heterogeneous catalysis involves the catalyst being in a different phase, typically a solid interacting with gaseous or liquid reactants. Heterogeneous catalysis is extensively used in industrial processes. A classic example is the Haber process, where iron catalysts facilitate the synthesis of ammonia from nitrogen and hydrogen gases. In the petroleum industry, catalytic cracking uses solid catalysts to break down large hydrocarbon molecules into useful fuels. In automobile exhaust systems, catalytic converters contain platinum, palladium, and rhodium to convert harmful gases like carbon monoxide and nitrogen oxides into less harmful substances. Enzymes in biological systems also function as catalysts, speeding up essential biochemical reactions necessary for life. Surface chemistry is crucial in nanotechnology and material science. Nanoparticles exhibit enhanced surface properties, making them effective adsorbents and catalysts. For instance, gold and silver nanoparticles are used in medical diagnostics, drug delivery, and environmental remediation due to their high surface area and unique chemical properties. Adsorption is influenced by several factors, including surface area, temperature, and pressure. A larger surface area provides more active sites for adsorption. Temperature variations can impact adsorption types differently. Physisorption decreases with an increase in temperature, whereas chemisorption may increase initially but eventually declines. The adsorption of gases on solids also follows specific mathematical models such as the Freundlich and Langmuir adsorption isotherms, which describe the relationship between pressure and adsorption at constant temperature. A key concept related to adsorption is the adsorption isotherm, which describes the relationship between the amount of substance adsorbed and its concentration at constant temperature. The two most common adsorption isotherms are the Freundlich isotherm and the Langmuir isotherm. The Freundlich isotherm is an empirical model that describes adsorption on heterogeneous surfaces, while the Langmuir isotherm assumes a monolayer adsorption on a uniform surface with a fixed number of adsorption sites. Moving on to catalysis, it is a process where a substance called a catalyst speeds up the rate of a chemical reaction without being consumed in the process. Catalysts function by providing an alternative reaction pathway with lower activation energy. There are two main types of catalysts, homogeneous and heterogeneous. Homogeneous catalysts exist in the same phase as the reactants, typically in solution, while heterogeneous catalysts exist in a different phase, often solid catalysts in a liquid or gaseous reaction medium. Heterogeneous catalysis is closely linked to adsorption. In this process, reactants first adsorb onto the catalyst surface, where the reaction takes place, followed by desorption of the products. Examples of heterogeneous catalysis include the Haber process for ammonia synthesis, where iron catalysts help in the reaction between nitrogen and hydrogen gases, and the catalytic converters in automobiles that use platinum, palladium, and rhodium to reduce harmful emissions. The study of surface chemistry, particularly adsorption and catalysis, has profound implications in technology and medicine, from drug delivery systems to advanced materials used in nanotechnology. Understanding adsorption and catalysis is essential for advancements in energy production, environmental protection, and industrial synthesis. By controlling surface interactions, scientists and engineers can design more efficient processes, improve product quality, and develop sustainable technologies that benefit society. Surface chemistry, though often invisible, plays a fundamental role in shaping the materials and reactions that define our modern world. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.